So this is the first video for the Trig Identities unit, and we're going to be looking at reciprocal identities. We've been talking about reciprocal identities, we just haven't given a name for it. So if you think of sine, we've discussed that the reciprocal for sine is 1 over cosecant, and then we also have the other identities. So we have our original 6, but we're also going to talk about other ways to rewrite tangent and cotangent, since they use two of the points within a coordinate. So keep in mind that when we discuss these reciprocals, I'm going to choose a point on the unit circle. We'll be in quadrant 1, so it'll be positive x, positive y. And since we're on the unit circle, we will have a radius of 1. So let's start with sine theta. Sine theta is going to be 1 over cosecant theta, since they are reciprocals. And the coordinate point for sine on the unit circle is going to be y. And then keep in mind that sine theta will also be opposite over hypotenuse. So we'll talk about the ratio of the sides of the triangle, a right triangle. Cosecant theta is going to be 1 over sine theta. So this means that cosecant theta is equal to 1 over y. And since we are using the reciprocal of sine, it's going to be the hypotenuse over the opposite side. Cosine theta is going to be the x-coordinate on the unit circle, and this is equal to 1 over secant theta, and cosine theta is adjacent over hypotenuse. Secant theta is equal to 1 over cosine theta, and since it is the reciprocal of cosine, it is 1 over x on the unit circle. And we'll just flip adjacent over hypotenuse, so secant theta is evaluating the hypotenuse over the adjacent side. Tangent theta is going to be equal to 1 over cotangent, and tangent is going to be the y-coordinate divided by the x-coordinate on the unit circle. So this is going to be opposite over adjacent. And tangent, because it is y over x, and sine is y, and cosine is x, we can rewrite tangent theta as y over x, aka sine theta over cosine theta. This is going to come in handy because we're going to get some complex expressions, and the method that I use is if we can't easily see all of the reciprocals, we rewrite every trig expression in terms of sine and cosine, so we can easily, if we see sine in the top, sine in the bottom, we can rewrite that as 1, aka canceling them out. So rewriting tangent as sine and cosine will be very helpful. Cotangent is the reciprocal of tangent, so it will be 1 over tangent theta. And this is the adjacent side divided by the opposite side of a right triangle. And cotangent will be x over y. And then we can also rewrite cotangent theta as cosine theta over sine theta, because it is the ratio of the adjacent side over the opposite side. So we're going to use these reciprocals to solve examples 1 and 2. Well, not solve, I guess to rewrite them. So we have f of x is equal to sine x of secant squared x over cosecant x. Rewrite f of x as an expression involving tan x with no other trig functions. So it says involving tan x. This doesn't mean only tan x. It could be tan squared x. It could be 1 over tan x. It could be, there could be other powers or a ratio involved, as long as tan is the only trig expression involved in that. So we'll have f of x is equal to sine x times secant squared x divided by cosecant x. And I do want to talk about something notationally. Now, secant squared x, you'll see it written like this, which just means we are taking the entire expression of secant x and squaring it. Okay, on the calculator's weird because, let me see if I have it pulled up so we can look at the keys. I think I do. Yep, I do. Okay, so if we look, if you're in my class, we're not using a calculator this unit, but as you're learning, you can use it as a resource. So if we look on the keys, it uses sine of, it has the -1. That's the inverse. Okay, so if we see a -1 in there, that's going to be the inverse. But if we type it in, say I do I want to find sine of 1 squared. Okay, so I would type it in, and then I would add the second parentheses, and then I would hit the square key, and it will look like this in the calculator. So when you see it on paper, the 2 is going to be after the n for sine, but in the calculator, it's going to look like this, which next unit will have a calculator, but for this one, it's just, if you're using it as a resource, that's what it's going to look like. Okay, so we already talked about our reciprocals. So this is what I was talking about, rewriting the trig functions in terms of cosine and sine. I see that I have secant squared. The reciprocal for secant is going to be cosine. Now, if I look at secant up here, I see that secant here is, technically this is over 1, so it's in the numerator. But if I rewrite it as its reciprocal, that will move cosine to the denominator, okay? So that's the first thing I'm going to do here. So now I'm only going to have sine of x in the numerator. I have cosecant x down here originally, and now I'm going to use the reciprocal identity. I'm not changing secant to cosine. I'm using the reciprocal identity to rewrite secant. So now it's going to be cosine squared x in the denominator. So again, this is technically, if I had a 1, this is still secant, all right? I'm just rewriting it as its cosine counterpart as a reciprocal identity. And then we also have cosecant, and since cosecant is in the denominator, I can rewrite this as, technically it would be 1 over sine, but in this particular problem, I have 1 over cosecant x. And if we look back up here, that is equivalent to sine x. So this will be equal to sine x. Technically over 1, so this means I'm going to move sine to the numerator. So I have the original sine, and now I'm also going to be having an additional sine from the cosecant that was in the denominator. So 1 over cosecant is sine, and then I have the cosine squared x in the denominator. So I have sine times sine. We have 2 of the same terms, multiplying them together. Therefore, this is going to become sine squared x over cosine squared x. So we have the numerator and the denominator simplified to single terms, but the problem specifically asked to rewrite it as tangent. So I'm going to rewrite these in a more obvious form. So I have sine of x squared divided by cosine x squared. And in this unit, we're going to be using a lot of properties of exponents and then properties that we learned with rational equations back in Algebra 2, okay? So for properties of exponents, I can rewrite this as sine x over cosine x all squared. And if we remember our reciprocal identity, sine over cosine is tangent, so we have tangent squared. And this can also be tangent squared x. Now, you don't always have to rewrite it showing the property of exponents here. Usually in steps, if you look on other videos, they will go to this step and then immediately write tangent squared x. And you can do that. Because it's an identity, you can go ahead and write that equivalency. Question 2, let g of x equal cosecant x tangent x. Rewrite g of x as an expression involving secant x and no other trigonometric functions. Okay, so we have g of x is equal to cosecant x tangent x. All right, so again, my suggestion is to rewrite your functions in terms of cosine and sine, see what might cancel out, and then see how we can reduce it. Cosecant x, I can use its reciprocal identity, 1 over sine. So I'm going to rewrite cosecant x as 1 over sine x. And tangent x is going to be sine x over cosine x. Now from here, we are multiplying 2 fractions. So if we have any commonalities in the numerator and the denominator, we can go ahead and cross those out because they equal 1. So we're left with 1 over cosine x. The problem asks for secant. Cosine is the reciprocal of secant, so we're technically looking at secant x right here. It's just written in a different form, so I'm going to rewrite it as secant x. All right, that's the video for reciprocal identities, and then we will look at Pythagorean identities next.